We paid 3 AIs to build a live service. Only one delivered production-ready code. The task was simple: generate a full Python microservice using Flask to handle CRUD operations on a simulated database connection. The goal was production readiness. We defined the constraints: robust error handling, secure dependency management, and an adherence to modern REST principles. These weren't beginner exercises. The clock started. Each AI ingested the prompt, simulated the development environment, and produced their respective code commits. Phase 1, the initial scan. We ran the first pass through each submission, looking purely at syntactic correctness and functional completeness. GPT-4o delivered the most cohesive initial structure. It nailed the basic routing and dependency injection, achieving 80% functionality instantly. Claude Opus was highly verbose but structurally sound. It included a decent middleware layer, showing strong architectural awareness. Grok's submission was the most brittle. It used an insecure, flat file database simulation and struggled with asynchronous requests. But functionality is baseline. The real battle begins when we move from RIT runs to is it production grade. We drill down into the error handling. A production service must not only catch errors but communicate them meaningfully to the client. GPT handled client-side validation errors efficiently. Its response body was concise, mapping internal exceptions to clear for XX codes. Claude's error logging was deep. It logged the stack trace and attempted to log the user input leading up to the failure. Exceptional for debugging. However, this verbosity came at a cost. The token usage was unnecessarily high just to achieve basic logging. This brings us to security. The injection vulnerability surfaces are often found in the subtle details. Grok missed basic input sanitization on the search endpoint. A clear SQL injection vector was present in its initial query builder. GPT and Claude both correctly used parameterized queries, the industry standard defense against injection attacks. But Claude added an additional layer, proper input validation schemas before the query even hit the database driver. This attention to defensive programming is the line between a hobby project and commercial deployment. When we weighed speed versus safety, GPT offered the most balanced profile, rapid implementation with sound defaults. Claude offered the deepest architectural patterns, the most scalable foundation if you have time to tune it. Grok remains the proof of concept. It proves possibility, but not reliability in a commercial context. The winner wasn't the one that wrote the most code. It was the one that wrote the *right* code efficiently. GPT-4o emerged as the most reliable partner for achieving minimum viable product quality with minimal prompt engineering oversight. But if your project requires maximum resilience and you have the bandwidth for detailed review, Claude 3 Opus shines as a powerful co-pilot. The biggest lesson for you? Treat the AI output as a brilliant junior developer's draft, never as production code. The prompt is not the task. The review is where the value extraction happens. AI is not the autopilot, it's the co-pilot that requires your experienced eye on the horizon. If you found this deep dive useful for your development pipeline, let us know which LLM is currently winning your coding challenges in the comments below. Subscribe to Crisvik AI for more breakdowns on how to build production systems at scale.